Now that we know the basics of numbers, integers, whole numbers, things like that, we're going to get a little bit deeper into the mathematics behind it all. We're going to start solving equations. And here we're going to start solving equations using what we call the addition and multiplication properties of equality. So using the addition and multiplication properties. And I'll explain those in a second. But before we get into that, let's quickly just remember how to identify solutions to an equation. So the first thing you might ask yourself, well, what's an equation? How does that differ from an expression? We've already talked a little bit about that. An equation is different from an expression that it has an equal sign. So an expression would be something like 2 plus x. An equation would be something like 2 plus x equals 4. So keeping that in mind, we know that equations have solutions. And one of the questions you were asked in the previous chapter are questions like the following. Is negative 2 a solution to the equation negative 4x minus 3 equals 5? And what we said was, well, if we want to know if negative 2 is a solution to the equation, we're going to plug in negative 2 for the variable, x, and then we're going to see if both sides of the equation are equal. If both sides are equal, then negative 2 is a solution. So let's try that. So we have negative 4. I'm going to plug in a negative 2 for x, but before I do that, I put parentheses in there just to make sure my signs are all right. Inside the parentheses, I'm going to plug in that negative 2. Then I'm going to use my order of operations to simplify. So before I go off any further, let me also talk about the left side and right side of the equation. My equal sign is going to be what separates my equation into left and right. Anything to the left of the equal sign, I'm going to call the left side of the equation. Anything to the right side of the equal sign, I'm going to call the right side of the equation. So when I simplify the left side, I'm going to get positive 8 minus 3 equals 5. 8 minus 3 is actually 5. So because the left side and the right side of the equation are both 5, I know that yes, negative 2 is a solution to the equation. I can give you another one. Is negative 1 a solution to the equation 3y plus 1 equal 3? And what I'm looking for is I'm looking for when I plug in negative 1 for y, will both sides of my equation be the same? So let's see. The left side simplifies to be negative 3 plus 1, and negative 3 plus 1 is negative 2. And negative 2 is not equal to 3. Therefore, no. Negative 1 is not a solution. So good so far, nothing we haven't already learned. But what we're going to learn now is we're going to learn how to figure out what the solution is. So because we got negative 2, that doesn't mean negative 2 is a solution to the equation. That's just telling us that both sides aren't equal, therefore negative 1 was not the solution. So let's try to figure out how do we come up with a solution. That's what we're trying to answer here. How do we come up with our own solutions? And to do that, we're going to use a couple of properties. The first property we're going to talk about is the addition property of equality. And the addition property of equality simply says the following. If you have an equation like a equals b, and you add the same thing to both sides of the equation, I add some number c to both sides, my equation is still going to be equal. Because both sides of the equation were the same, adding the same amount to both sides doesn't change anything. By that same token, if I subtract the same amount from both sides of the equation is still true. I can add and I can subtract amounts from both sides of the equation. As long as they're the same, my equation is the same. This should be a b. Okay, so keeping these properties in mind, let's try an example and let's see where this comes in handy. So let's say we're given the problem, we're asked to solve for y, and the equation we're given is y minus 6 equals negative 2. So I have y minus 6 equals negative 2, and my ultimate goal is to figure out what y is. So I want an equation that looks something like this. This is my goal. So one of the things I can do is I can use the addition property of equality that I just learned to see if I can isolate y. Well, if I have y minus 6 and I want y by itself, I can leave y by itself by adding 6. Because what I'll have here is I'll have y minus 6 plus 6. And y minus 6 plus 6 will mean that my 6 and negative 6 will cancel out, and I'll be left with just y. Pay close attention to what I'm saying here, because we're going to keep going back and back to these ideas here. So essentially I'm going to have y plus 0. But because this is an equation and the addition property of equality tells me that both sides are equal only if I add the same thing to both sides, I also have to add a 6 to the right side of the equal sign. So I'm left with y plus 0 equals negative 2 plus 6. And negative 2 plus 6 is positive 4. So I end up with y equals positive 4. Now I've solved. Now let's go ahead and check. So to check, what I want to know is 4 a solution to the equation y minus 6 equals negative 2. And I'm simply going to do what I did a few seconds ago. I'm just going to plug in 4 for y and see if I get negative 2. So 4 minus 6 is negative 2. Because both sides of my equation are the same, I know that my answer is right. So yes, 4 is a solution to the equation. I solved my equation correctly. So let's try a couple more. Let's try the example. Negative 2 equals z plus 8. And just like before, my goal is to get z by itself. Z equal to some number. This is my goal. So if I want to isolate z, that is the number I want to isolate, I need to get rid of that 8 that's next to the z. So because I have z plus 8, well, if I want to leave z by itself, I can just take away 8. But the addition property of equality, remember, it's that if I have two sides that are equal, and if I take some number from the left side, I also have to take it from the right side. So I have to take 8 from the left side and the right side. So let's worry about the right side of the equation first. Z plus 8 minus 8 is just going to leave me with z. The plus 8 and the minus 8 are going to cancel out to give me 0. And then negative 2 minus 8 on the right side are going to end up being negative 10. So my answer is z equals negative 10. I got to my goal. This is exactly where I wanted to get. Remember when we're checking, so that's our final answer. Now let's check if our answer is correct. I am asking myself, is negative 10 a solution to the equation negative 2 plus z, negative 2 equals z plus 8. So I am going to plug in negative 10 for z. It turns out that when I add negative 10 plus 8, I get negative 2. So it means that yes, that answer is correct. So that was the addition property of equality. Now let's talk about the multiplication property of equality. That's the second rule we're going to talk about. And the addition property of equality relates to the multiplication property of equality in the following way. If I have two sides of an equation that are the same, sides A and B, left and right, I can multiply both sides by the same amount C, and both sides are still going to be the same. My equation is still going to be true. The same is true of dividing both sides. So if I have both sides that are the same, and I decide to divide both sides by the same number C, my equation is still going to hold true because both of my sides are still going to be equal. I have one caveat here, and that is that if c is not equal to 0, and c can't be 0 because if you divide by 0, you remember what happens. You get an undefined or undetermined answer. So we're going to use this property to try the following examples. So I have negative 5x equals 15. So I have negative 5 times x gives me 15. So I want to figure out what x is. So if I have negative 5 times x, to isolate x, what I need to do is I need to use the multiplication property of equality to leave x by itself. If I divide both sides by negative 5, what happens here is my negative 5's will cancel out. I'll be left with negative 5 divided by negative 5, which is 1. So I'll just be left with a 1x equals 15 divided by negative 5 on the right side will give me negative 3. So I'll get x equals negative 3. I should note here, whenever you see 1x, that's the same thing as x. There's always a 1 in front of that x that we don't see. These two are the same always. So if I write 1x on one side and just x on the other, I mean the same thing. Now, like always, let's check if our answer is correct. And to check, I ask myself, is negative 3 a solution to negative 5x equals 15? Let's check that. So I have negative 5 times x equals 15. I know x is negative 3. So the left side of the equation gives me positive 15. The right side of the equation gives me positive 15. Because both sides are the same, I know my answer is correct. I should also note here, I know that in these examples my answer is always coming out to be true. That may not be the case when you're doing your homework. If you do this check step and your answers are not the same, you did something wrong. You have to go back and see what it is that you could have done wrong. So this check, although it always looks like it comes out true, it may not always come out to both sides being the same. So this is why we check. If it doesn't come out to be the same, you did something wrong. Go back and check what you did wrong. So let's try another example. Let's say we have 3y equals negative 18, and I want to figure out what y is. Well, if I have 3, remember there's a times sign here, so if I have 3 times y, if I want to get y by itself, I can just divide y by 3. And whatever I do to the left of the equal sign, I have to do to the right of the equal sign. That's what the multiplication property of equality told me. So 3 times y divided by 3 will just leave y by itself, because these two 3's, 3 divided by 3 is 1, so that will just leave me with a 1y. And on the right side of the equal sign, negative 18 divided by 3, well, that's negative 6. So my answer is y equals negative 6. Let's check. I am going to plug in a negative 6 wherever I had a y. 3 times negative 6 is negative 18. And because the right side was also negative 18, I know that my answer is correct. Let me give you a couple of more for you to try out in this type of problem. So one of the problems you can try is negative 32 equal 8x. And also try out negative 3y equals negative 27. And I want you to solve for x and c and solve for y and d. So one of the things you might be asking yourself is, well, when do I know when to add numbers to both sides, subtract numbers to both sides, or multiply or divide numbers from both sides? So let's just quickly go over how to identify the appropriate property. So if I have 3x, the following problems: 3x equals 15, 3 plus x equals 15, negative 5x equals 20, and x minus 5 equals 20. In this one, I'm going to divide both sides by 3 because I have 3 times the number of x's. So if I just divide the x's by 3, I'm going to have only 1x left. So this is going to use the multiplication property of equality. Go back to the previous page if you need a refresher on what the multiplication property of equality is. Here, I have 3 units more than x. So if I want to isolate x, I can just take those 3 units away. So here I'm going to use the addition property of equality to subtract 3 from both sides. Here, I have negative 5 times the number of x's. So I'm going to use the multiplication property of equality to divide both sides by negative 5. And here I have x minus 5 equals 20. So if I'm missing 5 units, I can just add those 5 units and x will be left by itself. So I'm going to use the addition property of equality here to add 5 to both sides. So it's important for you to know whether you have to add a number, subtract a number, multiply, or divide by a number. It does make a huge difference in your final answer. Let me give you one more example before I let you go in this section. And that example is the following. Let's say you have x divided by negative 4 equals 7. Okay? So if I have x divided by a number and I want to isolate x, if I have x divided into 4 pieces, if I multiply x times 4, that's going to leave me with just x. So what I'm going to do here is I'm going to multiply the left side of the equation by 4 and the right side of the equation by 4. And I'm going to make it a negative 4 so that when I take this negative 4 divided by this other negative 4, they cancel out to be just 1. So I am left with a 1x equals negative 28. So my answer is negative 28. And again, we can check this. I start with the original problem, x over negative 4 equals 7. But my x is now negative 28. And negative 28 divided by negative 4 is positive 7. So because both sides are the same, I know my answer is right.